So hello everyone, how are you all? I welcome you in this particular video. In our previous video regarding Laplace transform, we discussed about the first shifting property, we discussed about various fundamental properties of Laplace, and we discussed about the very basic topics, and we derived some of the formulas and vagera vagera. So in this particular video, we are extending the properties of Laplace, how you can solve the important type of questions, important type of properties with their derivation also. So without wasting the time, let's start. So particularly in this video, we will understand the multiplication property of Laplace. Multiplication property means when you are multiplying t with the factor that is f of t, then how will be the original result of this particular property? Let's see that. So Laplace transform, let's get the heading. For just quick recap, I am writing the first shifting property. Laplace of f of t, it is a function of s, and if you write function of s as a bar of s, that is a bar of s, then if you multiply by any exponential factor, that is e raised to power at, where a is any type of constant, then Laplace of e raised to power at times f of t, that would be a bar of s minus a. Just simply subtract this term a from s and put s minus a in place of s in the original formula, then that would be your first shifting property. Why it is called first shifting property? Because you are shifting s towards s minus a. Something is shifted, that's why it is s minus a, right? So in this video we will understand multiplication property. So let's write the heading of this multiplication property. Right? So Laplace of f of t, if this factor is multiplied by the variable t, so Laplace of t times f of t, right? So Laplace of t times f of t, provided Laplace of f of t is a bar of s. So Laplace of t times f of t, that is multiplied by t, this factor, so that would be, right, minus d by ds of f bar of s. Just you get the derivative of the f bar of s, right? The Laplace, just you get the derivative, the function of s, right? The Laplace, and you put the negative sign over here. That would be simply your the multiplication property. When the factor is multiplied by t, you just get the derivative of the irrespective of this, irrespective of the s of the original function, that is f bar of s, and put the negative sign over here. That would be the simply, right? So how we can derive it, and we'll see example problems on this. So right, so proof or derivation, what you say. So Laplace of f of t, right? So Laplace of t f of t, Laplace means combination of three particular things, that is integral, exponential and factor, So by the basic definition of Laplace, we can write that Laplace of t f of t can be written as integral 0 to infinity e raised to power minus st into factor. What is the factor? This whole is a factor. Not only f of t is factor, but also this t f of t is the factor. So t times f of t dt. What is in right hand side? That is minus dy of ds of f bar of s. So r is this. Let's write r is this. What is r is this? Minus dy ds of f bar of s. Are you getting? So minus f bar of s. What is f bar of s? That is Laplace of f of t. Laplace of f of t. What is? Integral 0 to infinity e raised to power minus st into f of t dt. Right, by the basic definition. I discussed in our previous video. If you not watched, then particularly watch this video. I will put in description box. Right. So integral 0 to infinity e raised to power minus st into f of t dt. Now, whenever there is upper and lower limits, that is 0 to infinity, now we are differentiating the integral. So what is the rule? That is Newton-Leibniz rule. That is Newton-Leibniz rule. So we will apply Newton-Leibniz rule. Newton-Leibniz rule, it is also available on my channel. Newton-Leibniz rule of calculus or limits. You can search this video, then you will find this particular video. You can watch particularly this video, and if you know, then no need to watch, right? So we are differentiating with respect to s. So consider t as constant, just differentiate with respect to t, right? So minus as it is integral 0 to infinity. Now f of t as it is, because it is function of t, no need to consider it because we are differentiating with respect to s. Now s is the variable, now consider t as constant, right? So f of t, now what is the derivative of e raised to power minus st? E raised to power minus st into the constant. What is constant? That is minus of t. So e raised to power minus st into minus of t dt as it is. So this minus with this minus will result plus. So that is going to be integral 0 to infinity e raised to power minus st into t f of t dt. And what is this? This is integral, exponential and factor. Now this whole factor is like that. So by this we can write it is Laplace of t f of t. So it is Laplace of t f of t. Right? So Laplace of t f of t is minus d by ds of f bar of s. Right? Just you get the derivative of the f bar of s and you put negative sign over here. So it is the derivation of this property. Now I will be showing one important problem regarding that. Okay? Let's erase all these things. Right? You can note. So question, that is Laplace of t sin t. Now their factor is t and the original that was sin t. So at first find Laplace of sin t. Laplace of 80, sin of 80 was a upon a square plus a square. What is a over here? That is 1 into t. Right? 1 into t. So 1 by a square plus 1. So if that is multiplied by t, you just get minus d by ds of this factor f bar of, right? So that will be 1 by s square plus 1 whole square into derivative of that by chain rule to 2s minus minus it will be plus, right? So it will be the simplest calculation. You no need to write the integration, you don't need to write the integration by parts, successive integration. Just this property ko use karo, just use this property, that is multiplication of t and get the derivative of this f bar of s. It is f bar of s, right? Function of s, that is Laplace of sin t. If that is multiplied by this t, then it will be minus derivative of, and you put the negative sign over it. That sign is very important, right? Some students get a mistake over here, that is minus sign. So put the minus sign over here, right? So another example I am showing, that is Laplace of t raised to power 5t sin t. Now we can use property number 1 and property number 2 simultaneously over here, because whenever there is exponential factor, just think, apply your brain over here. That is application of first shifting property, right? Application of first shifting property. If any of the factor is multiplied by exponential factor, then it shifts towards s minus a, right? If e raised to power 80 was multiplied over here, right? According to the first shifting property. So we will take first Laplace of sin t. So Laplace of sin t, Laplace of sin of 80 was a by a square plus a square. We derived also. You can particularly check out that particular video also. So Laplace of sin t was 1 upon a square plus 1, right? So Laplace of e raised to power 5t sin t was, that is f bar of s. We can write f bar of s. So it will be f bar of s minus a. What is a 5? So f bar of s minus 5. Just put s minus 5 in place of s, 1 upon s minus 5 whole square plus 1, right? Now if you multiply it with the factor t, that is multiplication property, now you get the derivative. So minus d by ds of this factor s minus 5 whole square plus 1. So I hope you can find the derivative of this by using the quotient rule or u by v rule, or simply 1 upon x format se bhi you can do it, right? So it will be the original answer. So in this question there is combination of two property. One is first shifting property, another is multiplication by t property. So I hope you understood this particular video very well. If you have any doubt regarding any particular topic, regarding any particular place where you didn't understand, you particularly make comment on the comment box. I will try to answer them separately. Okay, I hope you understood this video very well. I am getting students. So thank you for watching this video.